we need to prove cos inverse z is equal to minus I log z plus or minus under root of z square minus 1. Okay, so we'll take this LHS cos inverse z is equal to say some y. Therefore, from here cos y. So cos inverse z is equal to y. Therefore, what I will do, I'll take cos to this side. So cos y is equal to z. Okay, cos y is z. Now what to do is, now we know the formula for cos y. I mean cos x we have here. Cos x is e raised to ix plus e raised to minus ix upon 2. So using that formula, we will simplify this. So I will write here cos y equal to z, that is cos y means e raised to iy plus e raised to minus iy. Okay, you can put x also, no problem. Any letter you can put here. So e raised to iy plus e raised to minus iy divided by 2 is equal to z. Okay, see, be careful while writing 2 and z, both will look like the same. Okay, so be careful there. So now what to do is, this is e raised to iy plus, I'll take this to the denominator. This is 1 upon, okay, before that what we will do, e raised to minus iy, take this 2 here. So that is 2z. Okay, 2z. Now this e raised to minus iy we will write as 1 upon e raised to iy. We know it because 1 upon e raised to iy. Because we know 1 upon x raised to minus n will be, or 1 upon or x raised to minus n is equal to 1 upon x raised to n. So power when you take to the denominator, it becomes positive. Okay. So this. So like that, here e raised to minus iy, I took it to the denominator, so it became e raised to plus iy. So now what to do is, now take LCM. So again, if you find it difficult to put e raised to iy and all, just take, if you want, just take e raised to iy is equal to say m. Okay, I will take like that and then it will be easy for you to solve. So let e raised to, this step is not necessary to do. If you find it difficult to simplify using this e raised to iy, then only use this one. So e raised to iy, I am putting it as say m. Okay, so m plus 1 by m is equal to 2z. Then here multiply, m into m is m square plus 1 divided by m is equal to 2z. Okay, that is, now multiply m here. So m square plus 1 equal to 2mz, or that is m square, take this to the left side. So 2zm plus 1 equal to 0. Now this is a quadratic in m, like ax square plus bx plus c. This is a quadratic in m. Therefore we know what, if for ax square plus bx plus c, equal to 0, we know the formula, x is equal to minus b plus or minus under root of b square minus 4ac divided by 2a. Now hope you remember this. This is in 10th standard. So using that formula we are going to do this one. Therefore from here what you will write, therefore, so this is the formula we are using. That is not a part of this. So from here m is equal to, so this is a quadratic in m. So this is the coefficient of m. So m is, see, ax square plus bx plus c. So x is equal to minus b. Minus b means coefficient of x. Okay. So here coefficient of m will come. So m is equal to, minus is already there. Then b here it is minus 2z. So minus b plus or minus root of b square. B square means minus 2z square minus 4 into a. A is coefficient of x square. So here coefficient of m square. Coefficient of m is 1. So 4 into 1 into c. C is 1 divided by 2a. 2 into a is, again coefficient is 1 here. So you are just comparing with this one. Okay, 2 into coefficient here it is 1. So that is m is equal to minus minus plus. So that is 2z plus or minus under root of, this is 2z the whole square means 4z square, negative becomes positive, minus 4 divided by 2, or this is equal to 2z plus or minus. Now 4 is common here. So we are taking 4 outside. See, 4 is inside the root. When that 4, so it is 4 into z square minus 1. When this 4 comes out of the root, square root of 4 is how much? 2. Okay, so it is 2 into square root of z square minus 1. We took 4 common outside, divided by 2. Now if you look, 2 is a common factor everywhere, so that is 2 into z plus or minus under root of z square minus 1 divided by 2 is there. 2 gets cancelled and we are getting m is equal to, therefore m is equal to z plus or minus under root of z square minus 1. Okay, now what is m? M is e raised to I y. Now, m is e raised to I y. Therefore, because we substituted like that, see, e raised to I y is equal to m. So, m is e raised to I y, that is equal to z plus or minus under root of z square minus 1. Okay, now we need the value of y. See, we have to prove. What we have to prove? We have to prove y is equal to cos inverse z is equal to, means we need to get the value of y. Okay, so what we will do here, I will take log on both sides. Log of e raised to I y is equal to log of z plus or minus under root of z square minus 1. Okay, now this is which form? Log m raised to n. Log m raised to n is n log m formula. Okay, so log m raised to n is n log m, therefore this will be I y into log e is equal to here log of z plus or minus under root of z square minus 1. Okay, now so log e, value of log e, actually here e to the base e is there. Okay, so log e value is log e to the base e is 1. Log e is 1. Okay, so therefore here I y is equal to log of z plus or minus under root of z square minus 1. Therefore, y is equal to, what to do? Take this one, I to the denominator, so 1 by I log of z plus or minus under root of z square minus 1. Okay, now 1 by I, see, I square is minus 1. What is I square? I into I is minus 1. Okay, I am taking 1 I to the denominator. I am taking 1 I here. So it will be, or you just divide this both sides by I. I square is minus 1. So what I will do? I square divided by I equal to minus 1 upon I. So I square by I means 1 I will get cancelled. You will get I is equal to minus 1 upon I. Okay, or you can write, take this negative to the left side. So we will get minus I is equal to 1 by I. So this you have to learn, 1 by I is equal to minus I. So this is minus I log of z plus or minus under root of z square minus 1. Okay, now what is y? Y is cos inverse z. Same way we can prove for sine also.